Well, I want to thank you all for coming tonight. My name is Sandy Wilmot, and I'm part of the Natural Resource Inventory and Mapping Committee, along with Karen McKnight, Penny Miller, and Ryan Oakes. I wanted to also thank previous members of our committee who helped along the 4-year path to get to here. It included Val Story and Christian Matthews and who else? Amy Golodatz and Pat Lamphere. So this is a process that was called for in our town plan this past time, as well as the one previously, to do an inventory of our natural resources in Underhill. So I'm really excited to be able to share with you what this group from Arrowwood Environmentals has done over the past 2 years to inventory our natural resources. If we had done this in 10 years ago, it would have been much harder, because over the past decade, the state has done a lot to improve its maps and its process to create forest blocks that are meaningful to what we do as far as conservation and planning. And groups like Arrowwood have been able to map other towns and draw from the experience of doing that. So thank you both. So with us tonight is Jeff Parsons and Michael Lew-Smith. Jeff is a wildlife biologist. His extensive work in Vermont and the region has covered a wide variety of ecological work, including habitat assessments and wetland delineations and restoration, among many other things. And Michael is a botanist. He has dedicated his career working with the Natural Heritage Program, among other ecological work, and he also helped start the Vermont Vernal Pool Mapping Project. Along with these folks, Aaron Worthley, who isn't here tonight, is their GIS analyst, and he lended his expertise in creating maps, creating online tools so that you can actually view those maps and have it tell you what it wants. They're going to talk more about that, along with wildlife corridor assessments. So there's nothing as exciting as seeing wildlife out in our forests and wetlands. And so here tonight are these two going to tell us what they've learned. Thank you.
Thanks, Sandy. Okay, so we'll start with a few introductory slides, and then I'll talk a little bit about natural communities, something about the natural communities, and then I'll hand it over to Jeff, and he'll talk more about the wildlife mapping and assessment. Okay? Go. Okay, bye. So the task that Underhill came to us with was from their comp plan, and also from including areas from Vermont Act 171 regarding wildlife.
Oh, you're okay. If you could just talk about that.
Regarding wildlife habitat and protecting wildlife corridors. There's 2 different phases to the project. One was a remote assessment, which I'll talk about in a minute, and then the second was more field investigation and kind of delving in a little deeper to the wildlife habitat work. So Sandy was right in that in the last 10 years or so, there's been a lot of work done on remote data and the availability of remote data. Everything from really high resolution aerial photography to elevation and LiDAR, and all these things together really make remote mapping a much more refined process than it was 10, 20 years ago. I did some of the first natural community mapping in Vermont on Mount Mansfield State Forest, and it involved hand drawing on large black and white printouts while you were in the field, and then going back and figuring out where that, it worked, but it wasn't great, right? And so we've come a long way from that. And in the past 20 years, Arrowwood has developed a methodology that is able to use a lot of the new data. And it's kind of an iterative process, and that one part leads to the next. And that's what it is we have listed on the left there. Land cover is what we start with, and we'll go through and talk about each of these things. And then all the natural communities build on the land cover, and the wildlife habitat work builds on the natural communities. Okay? All right. Is it? Oh, thank you. So the land cover is basically a broad categorization. Okay? What's forested, what's open, what's developed, what's wetland. Okay? Really kind of broad brush strokes. Right? But that's what we start with in order to start this whole process. Okay? The next one. So from that land cover, we start to divide that up into different natural communities. Okay? I'm going to talk about upland natural communities first. And when we think about upland natural communities, it basically all starts with the bedrock. The type of natural communities you have starts with what's underneath all the soil. Okay? The bedrock, the soil is built from the bedrock. What kind of bedrock do we have in Underhill? There's the different bedrock formations all listed here, and mostly schists and phyllites. Okay? And generally, for ecological purposes, bedrock is kind of divided up into, is it carbonate rich? Is there really a lot of calcium there, which lead to enriched soils in different communities, or is it more acidic? Okay? For the most part, most of the bedrock geology in Underhill is more of this acidic variety. Okay? There's a few inclusions of more calcium-rich bedrock, which kind of appear sometimes in very surprising and strange places. Okay? Right, next. And then on top of that is the surficial geology. So this is basically what's mostly glacial geology, and how does that shape the communities in the town? The vast majority of the town is glacial till. Okay, this unsorted mixture of different rock sizes and classes and sand, silt, and clay, and it's all just kind of jumbled, right? We all know this is glacial till. Most of the uplands in the town are glacial till. Okay? There's exposed rock. Okay, this hatched area you can see, obviously up the mountaintops, and a few other places. But I really want you to focus in on the lower valleys. Okay, the more blue colored here. These are glacial fluvial and glacial lacustrine deposits. Okay, so from rivers and lakes. Right? So down in the valleys, some of those areas were from Glacial Lake, Vermont. Okay? And if many of you have heard the story, but I'm going to repeat it because it's so cool. Back when the glaciers were receding, they formed a dam to the north that dammed up all the water, and Lake Champlain, Lake Champlain was basically 500 feet, deeper than it is today. And during that glacial lake, Vermont, it reached up into these valleys. Okay? Of course, then there was a catastrophic failure, and all that water rushed out. The lake lost 300 feet in a matter of a couple days, and then warm seawater came in, and you had the Champlain Sea. But up in this area, so in the lower areas, basically, is where you have these very different soil types. And it's also, as we'll see, where most of the wetlands are. Okay? So the upland natural community is quite a wide range of different natural community types, and you probably saw some of these on the map if you had a chance to look at those. I'm going to go through just to highlight some of the more interesting and some of the major types of the upland natural communities here. just to give you some sense of some of the highlights. Okay, next. So this is the list, and I think it's in the handout as well. What I did here was highlight in green some of the rare and uncommon natural community types in this state. Okay? So the light green ones are ones that are more rare, and then the darker green ones are uncommon. And this is listed in the S rank. S1 is the rarest type, down to S5, which are super common. Okay? So if you notice all the high elevation forests, right, they're all uncommon and rare, and then as well as a lot of the cliffs and the talus slopes. And then, of course, the super common stuff that we all know of are S5 communities. Okay? So, of course, we're all familiar, right? Like Underhill is blessed with high elevation habitats and natural communities, including alpine meadow and subalpine krumholz and the montane forests. There's different types of montane forests. But it really is a resource. Like these things are just so fragile, rare, and in peril, and they harbor so many rare species, right? And so they're really, especially up on Mansfield, it's really a gem in the state. And I know you all have visited them. In terms of the montane forest, there's kind of this gradation. You have the montane spruce fir forest, and then below that, it starts mixed with hardwoods, and you get the montane yellow birch, red spruce forest, and then down into the hardwood forest. But those montane forests, we've all walked through trails, and it's go ahead and hit the next slide. And it's these dense conifers, and they're wonderful as long as you have a trail, because getting through them without, as Jeff can attest.
Bring your machete.
Yeah, right. But that particular type of habitat is also very valuable for wildlife, which Jeff may talk about as well. Okay, next. Associated in some ways with the steep slopes and the high elevation are the cliff, talus, and outcrops communities. Open talus, this picture down on the bottom is from New Hampshire, so that's not Underhill. But just to give you a sense of what we're talking about when we're talking about open talus, in Vermont, they're not super common, but a lot of wildlife associated with open talus. In Vermont, what we generally get more common is talus, narrow strips of open talus at the base of cliffs, or even more common than that is that talus has some tree growth on it. Okay, and we call those talus woodland communities. Okay, also really valuable for wildlife. And so typically you'll have a cliff and then all that jumble of rock below, and then it gets colonized by trees, and so you have a cliff or an outcrop and then a talus woodland community beneath that. Okay. And then the matrix forests. So these are the forests that are the most common. They kind of form the background of the upland natural communities in the town. Northern hardwood forest being the most common. Okay, the sugar maple and beech and yellow birch and that kind of thing. Extensive in Underhill. 22,000 acres is what we mapped of northern hardwood forest alone in the town. It's the most widespread and dominant natural community. Okay, that doesn't mean it's all uniform. There's a fair bit of variability, but within that natural community, it's pretty extensive. Okay, go ahead, next one. And we all know what these look like. These are, we live in these forests and with these forests. Okay, the mixed conifer ones, the hemlock, northern hardwood, and red spruce northern hardwood, found on stream banks and river slopes, and also some kind of rocky knolls. A little less common, but also can form large blocks. Okay. Oh, and I want to shout out to Sandy Wilmot for the photos. A lot of these photos are hers, so thank you, Sandy. All right, so wetlands. As I mentioned before, most of them in the river valleys. Okay, and we'll dig into a little bit. Show some of the examples of those as well. All right, next one. Here's the list of what you've got in town. And again, the more rare ones are in lighter green, and then the uncommon in the darker green. Okay, next one. I just want to talk about a couple different types that you've got here. These riverine wetlands, basically floodplain forests and alluvial shrub swamps. These are the wetlands that basically occur along your riverbanks. And there's not a ton of them in Underhill. It's not like extensive floodplain forests along the Winooski, right? But these are really important because they're high functioning wetlands, right? So because they're along these surface waters, they're important for wildlife as wildlife corridors, but also for erosion control and water quality and flood storage, wildlife habitat, and sometimes even as natural communities. Okay, they also can be, especially floodplain forests, are often pretty imperiled. Okay, highly disturbed. Okay, so those are interesting lowland wetland communities in the town. Okay. So the marshes, you're also blessed with a lot of beaver wetlands. Now the beaver complex isn't technically a single natural community. It's really a conglomeration of many different natural communities that I've got listed there. The reason we don't map them out separately is that it's a dynamic system and it's constantly changing. But they, like this one here, I think is a maybe 55-acre wetland complex, right? And there's hundreds of acres in the town. Okay. Go ahead and hit the next one. And the next one, please. And Jeff may talk about this, but this interplay between open water and emergent vegetation like cattails and then shrubs, all intermixed in this mosaic, is an incredibly diverse habitat for wildlife. Okay? It's really important. So if we can just keep the beavers from damaging all our stuff, they do provide really important wildlife habitat in the town. Okay? Okay. And then finally, I wanted to mention the seeps and vernal pools. These are very small wetlands. And I showed this map. The blue dots are shown larger than they actually are, just so that you could actually see where they are. And this is the one exception to locations of wetlands in the town, right? These are not in the river valleys. These and a few other forested swamps are kind of perched up in the hills. And the seeps and vernal pools can be, as big as that stage, or, just very small wetlands. Okay, go ahead, next one. The seeps are basically just that, sources of groundwater upwelling that can stay unfrozen throughout the year, depending. And interesting habitat for lots of different types of wildlife. Okay, and then the next one. And then vernal pools, isolated pools surrounded by forests, typically that stay wet during the spring and then dry up in the summer, and have a whole different type of wildlife assemblage that rely on them. Okay. All right, so next one, I think that might be it. All right, with that, I will hand it over to Jeff to talk about wildlife.
I get to talk about the fun stuff.
Wait, my stuff was fun.
A lot of this work is done by Aaron through remote mapping because of all the wonderful resources that we have to sit at a computer and actually map this stuff. And he produces most of these maps. Michael does the mapping of the natural communities, and then Aaron actually takes those natural communities and turns them into certain types of wildlife habitat. And then I go out and field check them. So I've got the easy part, and I get to get up here and talk about it, I guess. But so the state passed a law, I think it's called Act 171, that mandated that all the towns in the state identify forest habitat blocks, or blocks of contiguous forest in which wildlife live. And then they suggested, and not all towns did this, that they protect these forest blocks and don't allow a lot of development in the middle of these forest blocks, and to try to maintain connections between these forest blocks. We maintain connections between these forest blocks because there has to be free flow of animals between these forest blocks to maintain genetic diversity. There's also has to be movement allowed because young of the year animals will disperse from their mother's territories and they may need to go to a different forest block. Or if you're an animal like a black bear, you're going to be visiting wetlands in the spring, berry bushes in the summer, and oak or beech trees in the fall, and those aren't always in the same forest block. So for a bear that doesn't have all those things within its own forest block, it may have to move between forest blocks. And so this data is suggesting that all towns develop a way to protect those corridors. They're not mandating it, they're just suggesting it. I live in the Northeast Kingdom, they want nothing to do with it, right? So they're not protecting those things at all. When we mention it, they just say, oh, we just shoot them, so why protect them? Okay, so the way we organized the wildlife information was in forest blocks, and within each forest block, we identified the variables or the attributes you see on the left side, and I'll go through each one of those. Next. So this is just talking about Act 171. I think I've already said everything there. As you may, it may be fairly obvious that some animals have larger home ranges than others, right? A squirrel doesn't need as much territory as a bobcat or a black bear. So the forest habitat blocks aren't all equal. Some are going to have some large animals, some are just going to have small large animals. But in this town and in most towns, 20 acres is the smallest forest block that's considered as a habitat block. And that was true here, like I said, as well. Next. So this is, there were 32 forest blocks in Underhill. This shows you some of them. Some of the larger ones, the Mount Mansfield, the ones between Poker Hill and Irish Settlement, and the ones between Pleasant Valley and Irish Settlement, and then the ones further to the west that adjoin neighboring towns, 28 and 24. But each contiguous unit, 20 acres or larger, was mapped. There were no small fingers narrower than 50 meters, no active agriculture within those areas. We did consider adjoining managed forest that may be young growth because they're cutting the trees on a regular cycle. Shrublands like wetlands and other shrubby areas are included, yes.
When you say there was no agriculture there, do you count maple syrup operations?
No, maple syrup would be within these habitat blocks. Yep. All right, next. That's the table. I don't expect you to look or to memorize it. I will give you a quiz, but this provides all the information for each of the habitat blocks, and all the way up to what percentage of the habitat is preserved, what's the lowest elevation in the block, what's the highest elevation, because that says a lot about things, you know. For instance, the Mount Mansfield block goes from, well, I don't know the exact figure here, but it probably has, 2,500 feet range in elevation. Deer yards, wetlands, early successional forests, ledge habitat, all the stuff we're going to talk about next. All right, so some key elements. The first one is you take each habitat block and you come in from known, or not known, but human activity 100 meters. Because it's thought and it's known that the first 100 meters is called edge habitat, and it's qualitatively different for many species of wildlife. Things like bobcat don't like to, for instance, develop home ranges there. Certain birds that live in that edge habitat are frequently predated upon. Their nests are destroyed by raccoons and snakes and the type of animals that live closer to us on the edge of these habitats. So that's called core forest. So that's just taking these habitat blocks and coming in 100 meters on all sides. And that 100 meters is different in every type of ecosystem. But for our temperate, broad-leaved, sugar maple forest, 100 meters is the best. Science can tell us that the edge effect extends into the forest habitat block. So these areas are important because they provide home ranges for our more sensitive, human-wary species such as black bear and bobcat. We see black bear and bobcat everywhere, but where they're breeding and where, in particular, female animals are defending home ranges, males don't really defend home ranges. They just move to different female home ranges. Females stay put and have the best resources and defend them. And that's where you'll find the female home ranges of species that are sensitive to the human presence on the landscape. Bobcat, fisher, moose to some degree, black bear. Well, anyways. All right. I already mentioned that there are birds as well that don't do as well in terms of producing young that live to reproduce themselves in edge habitat. They do better in this core forest, a long ways away from edge habitat. Humans, edge habitat has a different microclimate. There's wind, there's sunlight, different seeds can reproduce there, different plants can reproduce there. So it's quite different. Next. The other thing we mapped, or one of the other things we mapped, is deer winter habitat. So during the summer, and most times when we see deer on the road or even in the woods, they're randomly distributed across the landscape. They're eating grasses and berries, and depending on what season it is. But during the winter, they become concentrated in a very small percentage of the landscape, dominated by evergreen or needle-leaf trees. The main reason is, and you may not think of this usually, but the cold air, thousands of feet up in the air, if you're a warm body down here, you would be exchanging your body heat with that cold air, and it would drain energy out of your system. And so they huddle underneath these evergreen trees. Broadleaf deciduous trees can't do it, right? Because they've lost their leaves during the winter. So the evergreen trees provide a thermal blanket to these animals. And remember, our white-tailed deer is the same deer as the Virginia deer. So it's really at its northern edge of its home range here. It disappears up in southern Quebec. So it has a hard time dealing with the cold winters here. And so it concentrates itself in certain habitats that are a small percentage of the landscape. Getting in your way, don't I? And we map those communities. Aaron and Michael map those natural communities. And who knows what the best one is for white-tailed deer? Hunters in the group? Hemlock, you got it. Hemlock and white cedar probably are both premier winter habitats for white-tailed deer. So as winters get warmer and warmer and warmer, you might think, well, they don't really need those habitats anymore. And they probably don't many years. For instance, all my field work last year, it was so warm. We had 6 weeks without snow, if you remember last winter. Deer were everywhere. They were at high elevations in maple forest. We did find some concentrated tracks in some hemlock forest. But this year or next year may be different. And if we get extended periods of cold and deep snow, where the snow is greater than 15 inches on the ground, which really hampers the movement of deer. If you think of deer, they're not very tall, as opposed to moose. And moose can also lift their knees above their head. So they can walk through deep snow quite readily. I've seen them do it. It's pretty funny. It's like spiders, you know. It's funny looking. So last year there was very little deer yard use, but the state continues to protect deer yards. I think towns should continue to protect deer yards because, you know, we don't know what's going to happen in the future in terms of our winters. And we can still get die-off when we do get those cold winters. And we can lose deer to, it's basically starvation, because that drain of energy doesn't stop until we start to get buds and grass growing. They can eat all they want, the branches that during the winter, and they'll still die. Maybe even with a full stomach. There's just not much nutrition in winter branches. All right, next. Those habitats, by the way, provide habitat for a lot of other animals as well, those evergreen forests. When you walk or snowshoe or ski through the forest in winter, if you're in a big open northern hardwood forest, you don't see an awful lot of tracks. But when you start to get into a mixture of trees with, you know, evergreen and deciduous trees and patches of spruce and fir and hemlock, that's when you start to see the tracks. Both the predator and the prey, right? The predators know that the prey are there. Typical hemlock forest in Underhill. And here was a spot where the trees were gathering under these ridgeline hemlocks. I can't remember where that was, but next. Another important habitat we map are early successional habitats. And they were concentrated in the shrubby wetlands along the creek. Up here, what's this, Mullen Road, I think. And down here near Ethan Allen in particular. These are both wetlands and early successional fields, although I think most of that are shrubby wetlands in particular. So these areas have a high density of small mammals that predators know are there. In particular, you know, you get a lot of rabbits and snowshoe hare, which of course things like bobcat and fisher and other animals like. All the weasels like as well. So these habitats are sought after as well. There are even some birds that utilize these early succession habitats. I think there's been a lot of research showing that just before birds migrate, they go to berry bushes in these habitats and eat a lot of berries to get quick energy before flying. All right, next. Forested riparian areas. So this is, really important when you have forested areas following streams in unforested areas, right? In a matrix that's hostile to most species of wildlife. It may take on added importance in those habitats, but it's also important within a forest habitat block. There's a lot of wildlife movement along stream courses. Coyotes use stream courses preferentially. Of course, the aquatic mammals like otter, mink, belted kingfishers use those forested corridors. Shorebirds, waterfowl use them as well, and wood turtles are using those habitats preferentially. And again, there's many other things that are important, or important values that arise from forest riparian zones. Our small streams, a large portion of their energy budgets that feed the biological organisms within the streams, and I mean mainly the insects that fish eat, of course, that they're fed by the coarse woody debris, trees and branches and leaves that fall from these forested riparian areas into the stream. A study in New Hampshire found that 40% of the stream energy entered it from these forested riparian zones. So They can be very important. Next. So masting stands are trees or berry bushes, but in this case we're mainly talking about trees that synchronize their production of nuts over a region. It's thought that if they produce many nuts over a region, there won't be enough for the animals to eat, and some of them will still be there to reproduce into trees. We don't know why, we really don't know why trees do this masting thing, where they tend to produce all in groups together within a region. But the animals certainly know it, and turkey, deer, bear, in particular, seek out these mast stands. We know that in certain regions of Vermont that, certain regions in Maine that we think are similar to Vermont, where research has shown that the reproductive success of black bears is directly tied into the production of mast species. It's a fatty food source that helps animals survive and reproduce and maintain weight before going into hibernation. There's one stand at Sugar Bush over in Mad River where I GPS 1,700 scarred beech trees in one stand. And bears come from 100 miles away to visit that stand. They ignore the fact that they're usually territorial. There'll be bears in nearby trees waving to each other, eating those beech nuts. They climb the trees. They leave the scars on the plain or smooth gray bark. You don't see it on the oak as much. You rarely see scars from bears climbing on the oak that you see in the beech trees. They're very difficult to map. These polygons here are largely drawn from aerial surveys done by Forest Parks and Recreation within the state, where they map beech bark disease. We also, do some mapping of it. You don't differentiate, do you, within your northern hardwood?
Unless you're walking on the ground, it's hard to map out the beech of the rest of the northern hardwood forests.
Yeah, very hard. For instance, there's nothing shown here, right? What is that, 15,000 acres or something here? There's a couple of little beech stands within the Mount Mansfield Forest Habitat Block. We didn't spend much time there in the field work, and I didn't find a single large beech stand in my field work during the winter. I found scattered beech trees and stands of maybe 10, 20 trees that showed evidence of bear, climbing them. It's an amazing thing to see out in the woods. Everybody's seen it, or a bunch of you. You've seen the nests that they build. The bears, right, grab the branches and strip them and shove them under their butts, and these big old nests build up in the trees. And it's pretty impressive to see, especially in fall, because you can look out and see them, or spring, without the leaves on the trees. They're very visible. Likely to be many more here that have not been identified. This stretch here, what's this, Poker Hill and Upper English Settlement? Yeah, quite a few in here, which I did see some in the field. So the soft mast, which are the berry bushes that many species of wildlife look for to eat the berries, are transient. They're only there for a short while, right? And then they go away. So we don't usually map those. But you know where you find them. You find them along logging roads and things like that. And you walk through those things and you see it. Oftentimes you find bear scat, or you see it where it's parted the ways and gone through and eaten berries. Okay, next. So this was a picture of a recent. So recent bear scars are light brown. After 2 or 3 years, they turn black, and that's what you usually see. And they raise, they pucker, and this is yet to happen. So these are real recent. These are a year to 2 old, or 2 years old scars here. Okay. bear wetlands. So in spring, when bears come out of their dens, they head to these wetlands where groundwater is discharging because the air is still cold, but the groundwater is warm. And that creates an early green up of leafy vegetation that the bears know about. Many of the sightings that you guys reported when we recorded local wildlife sightings were, near or in bear wetlands, including the creek. The creek has, I've driven by the creek for 40 years and loved it. I think when I bought my kayak on the way home, I stopped there and kayak before it got really filled in. But I didn't appreciate how wild that creek could be in places. And in one day, I saw 3 otter in the creek habitat. And I think that it can be quite, secluded at times because it's down lower than the road. And there's usually vegetation to buffer it from the road. So things like animals like like black bear feel fairly, okay there, especially maybe if they're on the other side of the road from Route 15. We've got those maps up here by Mullen Road. We've got a map here in the creek. We've got them in the big beaver flowages up here. I'm blanking on the name of the road up here. Oh, I want to say, I was going to say Sealy, but I know better. Siley Road. I was wrong again. I'll never get it right. All right, next. So these are the types of wetlands that the bear like. Not all of these ones are sites of groundwater discharge where they're dominated by warmer water. Some of them are associated with streams where it wouldn't necessarily green up that much earlier, but it's really lush, and it's before you start to get the leaves and the buds on the trees. And when you've got a bear in these wetlands, it's not like a deer that's nibbling. It's like an acre mowed down to the ground when a bear has been in there. This is the creek, actually. I saw three otter that day, and then I saw 2 more on Upper English Settlement Road. Same day. It was a great day for otter. All right, next. I should say it's a great day for me. I don't know if the otter... Ledge, cliff, and talus habitat. Michael talked about it a bit. What's really important is ledge that's broken. So it comes down, and then there's a break. And there's a place where an animal can tuck itself in and defend outward. In particular, it's thought that bobcats need that type of habitat, especially with coyotes moving in. They apparently, as long as coyotes can't get behind them, they're able to defend themselves, front forward out in these cavey type environments. There are also places where it's thought that they raise their young in these habitats, in ledgy habitats. Supports many rare, threatened, and endangered species. And then the ledges that don't have the break, or if they do have a break, there's enough area high up to protect species like peregrine falcon and raven from predators. These areas are scattered throughout. These ones are really high. It's unlikely you're going to find a lot of bobcat living in an environment like this that has deep snow. That would be more the lynx, right? Bobcat don't like deep snow. So I think some of the lower elevation ledges are probably more important. Broken ledges, that is. It's always a good thing to, when you see a ledge like that, to peek inside. You'll find scat, you'll find bones, from where a predator went in there and ate small mammals or other animals. You'll see hairs stuck to the side sometimes. In particular, black bear leave hairs stuck to the side. But anyways, they're great spots to look for wildlife sign. Next. Corridors. So Aaron did 2 different methods to map corridors. he did a town-wide mapping where he only mapped the most important corridors, which would be the darker pink here, and he ranked them based on the permeability of the landscape. So he didn't take white-tailed deer and say, where do they cross? The white-tailed deer cross anywhere, including your backyard. He took bobcats, or we did over many years, black bear, fisher cat, find out what type of habitats they like to use to cross roads in particular. And then you assign a numerical value to the landscape that is equal to its permeability to that type of wildlife. So if it has a high permeability, that's good. That means the wildlife, moves through those areas preferentially. And you can see the different areas here that are mapped. So this is town-wide, and so you're comparing, the best with the pretty good still. So there's none in here. Next. Here's linkage corridors that are drawn for the entire town. So, this probably isn't as good as some of the habitats that were dark pink up here, but it's still important if you're interested in maintaining, movement of wildlife from here to here. And all these linkages are drawn in relationship to moving from one habitat block to another, okay? And so this is looking at the entire town and maintaining corridors. So in a place like this, you're not going to find a 200-acre forest, right? You're going to find a 2-acre forest or 20 trees or something. We call those stepping stones. And they're very important for wildlife moving through these habitats to have somewhere where they can feel somewhat secure while moving through a human-dominated landscape, right? And we often recommend that towns consider protecting those stepping stone habitats if they want to maintain connectivity throughout the town, not just between the wilder forest blocks. All right, next. See, I'm running out of time here. The work we did to field verify. My field work, because of a lack of snow and because I tried to get access to each of the forest blocks. So I requested, I think, at least one parcel in most of the forested blocks. That wasn't possible. We couldn't get that permission, and we don't do our work going onto people's land without their permission. We did rapid road tracking, and Sandy and other people helped me do that by driving like on Route 15, and I have a little app on my phone that says deer, and I press it when I see a deer track, and we drive along with the flashers on. You probably saw us this winter doing that. It wasn't a great year for tracking wildlife. The snow wasn't very good. We did find that the mapped corridors did not correlate very strongly with the animals we saw on the road, and that's for two reasons. One, the lack of snow allowed animals to move through a wider variety of habitats, but it also because Underhill has a pretty good connectivity throughout the landscape, which means that they weren't forced into these narrow crossings. They could cross in many places. That doesn't mean that you don't have to think about maintaining that because it's endless. It means you have a little bit of flexibility in how you can do that, right? All right, next. That's your information that you put on the site for wildlife that you saw, and 15% of those sightings were black bear. Got a lot of black bear in town. You know that already. Okay.
Well, so we're going to use the mics if we're going to ask questions.
So I have a question about, did you find a correlation between the citizen sightings and where you thought the wildlife corridors were going to be?
I don't know if we looked at that in detail. That's a difficult question, actually, because, you know, anytime wildlife's crossing a road, it's where it shouldn't be, really. And I guess it makes sense, though, that it should be in places where you expect it to be. But I don't think Aaron did that detailed work. All right, so the areas I chose to go to, when I go out in the field, I load up a map on my GPS and I put dots on it where I want to go to. And those dots are places like ledges, wetlands, forested riparian zones, early successional forests, edge habitat where several natural communities are coming together. And so I tried to walk in certain areas where I expected to see more wildlife. It was a very poor tracking winter. Even in my field work, I saw very few tracks because there often wasn't snow, or if there was, it was crusty. And even though I tried to choose my days after an inch or two of snow, but it wasn't always possible. So I did a lot of confirming the presence of natural communities that were mapped. I guess the highlight was 4 river otters in one day. And I saw a 5th a couple days later, which was pretty cool. All right, next. Hit the space bar if you would. Yeah. So Aaron put this together where he wanted to compare where the conserved land was and where there were overlapping features that I've just talked about. So where there may be a disparity between what was protected versus what the most valuable habitat on the landscape is. And as you probably already know, right, most of this is protected, right? In the Mount Mansfield was a state forest. And a lot less of the lower regions are protected, although you have some in here that's pretty good and pretty well protected. Is this McComber Mountain? And yeah. How's that pronounced? Okay. So I put together some takeaways. I think it's important to protect linkage habitat, particularly unless you expect no more people to move into town. Then you're fine just as you are. I kind of doubt that's realistic, right? Even in my town up in the Northeast Kingdom, it's not realistic. There's extensive aquatic and deep forest habitats in town. I would suggest that additional field work be done to verify wildlife crossing areas. And then it's up to you to decide if you want to protect them or not. I'm not going to tell you that, but just realize that your town is in good enough shape. They have lots of options. South Burlington, we did this for South Burlington, and they passed a law saying no more development in these habitat blocks. And then they called us and said, defend us in court, Hasn't happened yet. But you don't have to do that, right? You don't have to say no more building in these habitat blocks. You couldn't say that. But you could think about, design your developments to leave open space. Design your developments to leave open space close to the road, or forest land close to the road where wildlife can move. Have your lights downward pointing, or have the lights that only come on in a development when cars approach and things like that. So there are design elements within development that could be used as opposed to complete prohibitions on development. Next. All right. As you probably know, this entire project is online, and it's interactive. You can highlight and eliminate certain features, and you can see the work that we've done, and you can take that and add to it over the years. We will always keep this as is, but there's a process by which you can take it and make it your own and change it over time as well. And, you know, I encourage you to do that. I think that's probably it. I left you 45 seconds.
If you can come to the mic and ask your question that way.
David,
It doesn't.
sorry, usually red is record. Do you have any experience with transferable development credits as one way of properly balancing the landowners with those stewardship goals with the more urban people that want to just develop and take from those more rural landowners?
Not direct experience, but certainly, you know, we worked in 30 or 40 towns, and many of them use that process. Many of them are in Chittenden County, so Charlotte, Shelburne, places like that use them, I know.
Yeah, generally, our approach is, you know, since we're not town planners, we're more of the science-based folks. And so what we do is say, okay, here's the science, boom. Now you folks can do with it, you know, as you see fit. And some towns really take it and run with it. Other towns, of course, for whatever reason, it sits on a shelf, you know. So yeah, I guess just in response to that, we're sometimes brought into the planning process, but we don't spearhead that.
Yeah. If they ask us to comment on a specific one, you know, we'll comment if we worked in that town and know something about the land that they're talking about.
Okay, thank you.
Yep.
I have a question about seeps. You were talking about the seeps, and I think you said there were certain minerals left in the seeps, or maybe not. The water was different than the content in other areas. So, is there a relationship then between fens, bogs, and seeps? Because I know that fens have different type of.
Right.
Yeah.
Kind of. So depending on the bedrock, because you've got groundwater discharge, it's basically coming through the bedrock. If it's a nutrient-rich bedrock, you can get kind of maybe a seepy fen develop. Fens are a little more nutrient-rich than other peatlands like bogs. Okay? And so the common denominator really there is the type of bedrock that you'd get. But the seep community can occur across all types of bedrock.
And I wanted to talk more about those seeps. I think there are tons of them in the Mount Mansfield State Forest. And I think a lot of bear go to them. And the state tends to protect bigger ones, but man, I think those little ones that are buried within the forest itself, where the sedges come up early in spring, are really important for wildlife. I imagine they're like a magnet, you know. You think about it, everything's frozen and here's this open water and veg coming up. And
Yeah, the seeps and the vernal pools in particular, because they're so small, they're hard to map remotely. And so there's a lot more out there than we have identified. Yeah. And that's just the nature of the beast. And so that's why they're often also kind of fun finding them, you know. So, yeah. Okay.
Do you guys go by foot or do you drive?
Yeah, I mean, we drive to a site and then we walk out into the woods by foot.
we both have two-wheel drive cars too.
Okay, that's interesting.
Yeah. Yeah, we like to walk in the woods as much as possible, so we go by foot when we can. Yeah.
I'll just do it here.
Okay.
You were talking about a lot of otters. Is that a sign of really clean, healthy habitat?
I think it's a sign of a healthy food supply, and unless they're eating catfish, I think it's
You disparaging catfish?
if they're eating fish that depend on clean water, then yeah, it's a sign of that.
Yeah, a lot of, I think it's also the abundance of habitat, right? Along the streams and all the wetlands in the valleys there. There's a lot of that habitat. Mm-hmm. So there's a lot of otter, and Jeff saw them all.
They want their pictures taken.
Yeah, jealous. Wow. Yeah.
Did you stock some fish there for them?
No, we used to.
Okay.
We see the tracks all winter, but we seldom seen them in the fall.
Mm-hmm.
Yeah.
And they were just going back and forth and splashing and diving and splashing each other, and it was just like a joy.
Yeah.
Oh yeah. Do you have a stream or lakes
So
and?
we have big ponds, and we have a series of 4 ponds that kind of come and go at canal.
Yeah, yeah.
And then you went up to our saddle, and remember you came back and you said, we have like 8 inches of snow. And it was like nothing.
Nothing down below. Yeah.
That's great.
I also wondered about fishers. You said they were interior, and they like the interior. I always think of them on the edges after fork.
I think when I was saying their interior, I was talking more about reproducing. Many of the species that we see on the road, we see them on the road and we think they're okay. But if we eliminated the core habitats, the populations would decline greatly. So
And you no longer see them on the road.
Yeah, then you wouldn't see them on the road. So, I think that's a common misunderstanding, including one that I grew up with. I see all this wildlife; it's got to be everywhere, but you've got to maintain those deep habitats. I think for things like breeding.
Hey, just a thought. Do you guys work with the Vermont Fish and Wildlife Department? It seems like there's a lot of overlap here, especially with where things are crossing, where the stands are, where the wildlife is being harvested.
All the time.
All the time. As a matter of fact, our work in most towns is taken by Fish and Wildlife. Jens Hilke, he's got a new name now.
He does?
Well, he's married. Anyways, Jens, who's one of the state conservation biologists, takes our work and other work that other people do, and then ties it with nearby communities so that the corridors match up and stuff. So corridors doesn't run right into a village or something. And that's Fish and Wildlife that does that. Our state actually has a committed group of people that take it one step beyond what we do.
Do you let them input into your research though?
We're constantly consulting with them, and we use a lot of their data, and they use our data. And
Right.
So, yeah.
You bet.
Yeah, for example, the state land that managed Mount Mansfield, they wanted the natural community map that they finished so they could improve their own that way.
Yeah. And when I was mapping the communities, I made sure that I tied in my map where their map ended. I tied it in so it's a seamless transit, that kind of stuff. So.
Another round of applause for these folks. Just a couple of words about where we're going with the information. The Conservation Commission, the Planning Commission have been waiting for this information so that they can incorporate it into their work, trying to conserve and protect very valuable lands, planning so that we make wise decisions about where development is or isn't. We will be working with Jens Hawkins
There you go.
Hilke
Okay.
from the Fish and Wildlife, who works with communities to help us take this information and make it one step more usable in our planning, using it with our maps and that sort of thing. So we will be working with him on that part of it. What else? Yeah, that's the gist of it. Also, for landowners, with this information, we're hoping that it helps you kind of understand your own properties and what you might want to manage for to protect or conserve or however to make this great wildlife habitat continue into the future. I want to thank all the landowners who allowed permission to go on their property, because we couldn't have done it without it. And the town that has been supportive throughout this, as well as you who financed it. So thank you all very much for coming.